Well, good evening, viewers. Welcome to Space Oddities. Thank you for being with us here on this Tuesday evening. We hope you're all well. I can see we've got people piling in now. Welcome to Space Oddities. And if you're new here, thank you very much for joining us for the first time. We hope you enjoy yourselves. And if you're a regular here, well, you know what to expect. So this evening, we've got a few things lined up for you this evening. Daz is going to be talking about the Carrington event, and if you don't know what the Carrington event was, all will be explained. Lou's going to be talking about a mouthful. What was the mouthful, Lou?
Micro observatory.
Oh, that wasn't so much of a mouthful. Micro observatory.
Spread it out.
Yeah. Okay. So joining me this evening, the aforementioned, we've got Daz looking resplendent in his Arctic onesie or white Teletubby, or however you want to call him. We've got Roger. Hello, Roger.
Hello. Got my
Roger's flying the flag for Space Oddities,
Yes.
and the aforementioned Lou. Lou, we hope you're well over there in the US.
How's the weather? But somebody's got to do it.
Yep. Well, that's true. How's the weather in the US?
Oh, it's beautiful. This is observing weather.
Oh, yeah, it is here as well. Beautiful, clear skies. Do you know, when I went outside this morning, about 6 o'clock in the morning, Orion was setting in the west, and I thought, "Oh, winter's really coming, isn't it?" Because it was absolutely glorious at 6 o'clock.
You know they're rubbing salt in the wound, don't you, Rog?
Yeah.
Okay. We're so pleased for you.
Beautiful clean up. Of course, we've got a moon, so it's not great for observing tonight.
So we got a moon. It's
Yeah,
the same one. It's the same.
yeah.
I have escaped your notice, but it's the same one. So there was that lovely story that Pete Williamson told, wasn't there? Talking to a woman about the sun, and she'd been to Spain, and she said it was hot in Spain. He said, "Yeah, well, of course, a lot." So she said, "Yeah, but it's a different sun in Spain." So,
yeah, it's a different sun, and it's hotter.
Yeah, different sun, and it's hotter. Anyway, so we've got some things lined up for you. We'll have the weekly news section. It's been quite a busy week for news, so we've got a lot to get through today. But of course, to start things off, may I just say, don't forget to like and subscribe, please, because that really helps us a lot if you can manage to like and subscribe. Because it really helps the YouTube algorithm notice us and propagate us, as it were, through the ether. And we'd also like to say a big thank you to those of you who've been buying us coffees. As ever, you have our heartfelt thanks for that. And needless to say that if you would like to help support Space Oddities, there are a few different ways you can do it. But one of them, and one of the easiest, is to buy us a coffee. And if you scan the QR code, you can buy us a coffee, and the money goes directly and only into helping Space Oddities keep going, because nothing is free. We have to pay for all sorts of things. So any support you could give us to keep us on the road would be, as ever, greatly appreciated. And thanks to everybody who does that. We are touched by your generosity. So I'll just leave that up for a little while. Also, don't forget that we have the merchandise available, Space Oddities T-shirts and hoodies. The Space Oddities T-shirts are £19, including UK postage and packing. Please add £10 for foreign orders. And the hoodies are £35, including, again, UK postage and packing. Please add £10 again for foreign orders. Full details of the merchandise is in the description of this video. But before the end of the program, I'll pop a couple of QR codes up for you to scan to make it easier. Okay, well, let's move on with the show. So, and time-honored tradition, and a tradition that we would be very wise not to tamper with, because he would get very angry. Yeah. We go straight over to our resident eye on the sky. And it's Roger. What more can I say? What's up, Roger?
Okay. Well, clouds at the moment, but that's for another event. So here we go for the 24th to the 30th of October, coming round to November. But here we go. So we're coming at the full moon at the weekend. So it's bound to be clear then, as it would normally be. And so here we are for the night sky in the week. We've got Saturn still visible for a while yet, and Jupiter now dominating the horizon, as is the Pleiades and Taurus with Orion arising. Now, I've got this set for the 11 o'clock at night, so things are starting to rapidly appear for the winter constellations. And sadly, we've got the summer triangle now setting over in the west, unfortunately, but that's how it is. But dominating the southern horizon up near the azimuth, we've got Andromeda in the galaxy. So a good opportunity to get some nice Andromeda galaxy images. And of course, as the moon progresses between Saturn and Jupiter at this time, we've got a good opportunity for some photo ops. And as you can see, Orion now making a more focused appearance. Around about 6 o'clock in the morning, we've got Jupiter setting, but we've got a very nice luminous Venus up in the night sky. So when we've got Orion in the southern, we've got Venus coming up through the night sky. And if you want to see a comet, we've got one visible, which is now in Cancer, 103P Hartley. That's a bit more apparent. Here is its location, but it's not too bright, but there is an opportunity, especially after the weekend when the clocks go back. So,
oh God, it's that time again. Oh no.
It's that time again.
Oh no.
But we've got some new images from the web of Jupiter.
Wow.
Now this is focusing on some of the winds that they've got on some of the belts. And some of them have been tracked at 320 miles an hour or 515 kilometers. And these are roughly 25 or 40 kilometers up in the in altitude above the above that. So yeah, a wee bit drafty.
Just a tad.
Yeah.
Yeah, and they've been following some of the jet stream parts, and this has all been studied over one Jovian day, around about 10 hours. So it's been quite a fascinating study. This was done during middle of last year and has only been just reported this week because of all the projects that's currently on the go. This gives you some ideas of some of the speeds that they're getting, between 362 kilometers and 515 kilometers. So it'd be quite good for a wind. Get a lot of generated power from a wind farm from there, but
you would.
You wouldn't be able to put it up in the first place due to the winds. But
hang gliding would be
good. And it's yeah, so getting quite a bit of interest on the on that event. So there we go for the Jupiter.
Roger, I think
what
a lot of Jupiter observations in the infrared are done at 5 microns, which can distinguish heat sources. I don't know how this one was done, but I'm wondering if that would be the case.
Yeah, I mean, it's all done through the equatorial belt, so
it's NIRCam.
Yeah.
I'm sure NIRCam can.
Yeah, it says it on NIRCam.
Yeah.
Okay.
Quite fascinating. As you can see, July the 22nd last year, this was initially started. So we've got a bit. I've only got a couple of people that have put in entries this week. It's probably due to all the bad weather, I expect. But there we go. Right. First one is the Fish Head Nebula in Cassiopeia from Jerry DeLay.
Thank you, Jerry.
And we've got all his information there with his. I guess that'll be with his 100mm refractor. And this is what he's reproduced.
Oh, wow.
Yay. Nice image.
Yeah. Very good.
Lovely.
Yeah.
Oh, you can see how it's got its name, can't you?
Yeah. Mm. Yep.
Wow.
I always struggle with these. I never see what they say they are.
Yeah.
I see a fish.
Okay.
Definitely.
Yeah, definitely. Okay.
Coming through the murk.
Oh.
Oh,
Oh God. Fast forward. This is why you didn't see it in the earlier on in the presentation because of the lack of entries. But this was from a few days ago, and I've managed to get quite a bit of detail on this one from
That's nice, Roger.
couple of nights ago.
beautiful.
It's good how you've got a lot of the valleys and stuff showing through here.
So is this done?
Both worlds, right? A
Yeah.
fair amount of shadow and a fair amount of the moon.
Mm.
Is this stacked, Roger? Is it?
It's from a video. It's it's basically just 1,000 frames.
Yeah.
And I just put the best 15% together to
15% of 1,000 frames. That's brilliant.
Yeah. So yeah.
And what software do you use for that? Do you use
Well, I use SharpCap to capture it, and then I just process it in Auto Stacker and just put it into Auto Stacker and Photoshop.
Oh, that's lovely, Jubbly. That's nice.
So that's a little AI application, isn't it, to select the clearest images out of the lot?
Yeah. There's
I mean, seems to be a go-to program which has been on the go for at least a decade or so. So.
And it's free, isn't it? If I remember
and it's free, yeah. I mean, the guy who actually created the software is doing version 4, but he's only doing it as and when he's got the time because he's not getting paid for it. Otherwise, it would have been out a few years ago. But apparently, it will be in the pipework at some point. But as and when, we just don't know, unfortunately.
Oh, you sounded like Patrick Moore then.
Okay.
And the answer
just don't know.
Yeah, right. And this is my version of Jupiter through my 7-inch Maxitoff.
It's a bit dark.
Yeah.
Well,
there we are. Turn the light on.
Yeah.
Holy Christ.
That's amazing, Rog. That's amazing.
Yeah.
I mean, not as good as the web.
I forgot that. No, it's not as good as the web. Not quite.
Well, it's different. It's not an infrared image, so it's going to look different.
That's right. Yeah, it is.
I thought you would have known that.
I mean, if I got a bigger telescope, you would have got some surface detail on Europa and Io, which some people do actually manage with a 14-inch scope.
They manage to claim that they see surface detail.
No, because if you look at some of Damien Peach's images, he does that all the time. He's got amazing detail with his kit. And viewers, if you don't know who Damien Peach is a master astrophotographer. He's, for my money, the best in the business, apart from Roger, of course. And you should look up Damien Peach, as in the fruit, because his images are absolutely stunning. If you're interested in astrophotography, he's the
he likes to image from the Caribbean due to the conditions over there.
Yeah, nice work if you can get it.
Yeah. And he takes his 14-inch Celestron in a big case to take over there.
Yeah.
It's absolutely scary to see that sort of thing in a trunk being taken from airport to airport across.
Yeah, it's not exactly hand luggage, is it?
Not at all.
No.
The gauntlet's been thrown down, Andy. Kev says Tom Williams and Martin Lewis are the current masters of planetary. So gauntlet has been thrown.
I don't know.
Pistols at dawn.
Let me just have a look in the chat. I need the name so I can go and have a look. Right. So let's put that up there. So
tell them to get on our show and prove it.
Yeah, absolutely. Yeah. Right. Okay.
Right.
Thank you for that, Kev. I will check them out. I'm not familiar with their work, but I will check them out. Thank you for that information. We will see.
And that is what we have for this week.
Okay.
Short and sweet.
Yeah. So obviously, as always, we'd like to say a big thank you to those of you who send in images to our gallery. We do love looking at them, and we think you're all very clever, and we're all very impressed. So keep them coming in if you would like your image to be featured in the gallery. then it's very easy. Send your image in an email, attach an image to an email, and mail it to spaceodditieslive@gmail.com. One image per email, please. And if you could entitle your email gallery entry or something like that, anything including the word gallery, it will enable poor Roger here to pick them out of the inbox easily.
Yes.
So there we are. And, as we say often, it doesn't have to be anything high magnification. If you've got a skyscape that you think is beautiful or interesting, or both, anything of the sky, basically, then, send them in, because we love seeing them, and we're very impressed. We are going to endeavor this Christmas to create a Space Oddities calendar featuring Daz is burying his head in shame. We are going to try to do another calendar this year, this time with the dates on, and we will look through the entries that we've had this year and pick out our favorites and include them on the Space Oddities camera calendar. More news of that as and when we get around to thinking about it, but we will be thinking about it soon, because Christmas is approaching us fast. So there you are. Talking of coming events, a week on Thursday, I am flying to Ireland to attend the County Mayo Dark Sky Festival. I've been invited to do a lecture there at the Mayo Dark Sky Festival. Obviously, I'm looking forward to that immensely. I'll be talking on the subject of gravitational waves. So if anybody's going to attend that, come and make yourself known to me. I'd love to see anybody from here if they're going to the Mayo Dark Sky Festival in Ireland. I will.
Is that in my honor?
Yeah, absolutely.
Okay.
Yeah, definitely an honor. I am honored, obviously, that they've invited me to go and speak. And I will be doing a roving report from the Mayo Dark Sky Festival in 2 weeks' time. So keep your eye out for that. And let us pray for great weather while I'm there, so that we can actually get out and do some observing. But the event happens all over County Mayo in Ireland. It's a big event, big festival. And I'm really, really looking forward to flying over there. Okay, so on the subject of images, then it's about time we went over to Lou. So Lou, what's this all about then? What are you going to tell us about?
Well, I have 2 undergraduate classes back here in the States. And we do a lot of hands-on activities in our astronomy class. And one of the things we do is we observe with remote robotic telescopes. And I actually thought that one of my students was going to send in their images for our gallery this week. Maybe he'll send it in next week.
Okay.
So one of the challenges is that they use the Micro Observatory robotic telescope network to take images.
Okay.
And I thought
let's put that up
this would be a good thing to show everyone. So I'm going to...
Yeah. Let's put that up there now. There you go.
Oh, are you going to... That's great. Are you going to do the slides for me?
Well, you can do that.
Can I? Well, I can't select on these hot links this way, right?
No.
See, this is an interactive session of our program. So take yours down. I'll put mine up.
Okay.
Okay. Now I'll put mine up. In theory. Share. There we go. There we go. So we should be seeing it shortly.
Right, let's put it up there then. Okay, here it goes. There it is.
Okay, very good. So Micro Observatory, this is a telescope network that is managed by the Harvard Smithsonian Center for Astrophysics. And I think it got started with some NASA grants. And the idea is to make telescope observing available to everyone. These are not highly sophisticated telescopes. They're 6-inch reflectors. I think there's one in Cambridge, Massachusetts. There's one in at the Whipple Observatory in Amado, Arizona. There may be another one, I forget. But the idea is to make it easy to take pictures through a telescope. And if you go to the Micro Observatory website, all you have to do is Google Micro Observatory. It comes right up. This is a network that's been in business since I think about 1995. So they've had plenty of time to do their user surveys and find out what works and what doesn't. So here we are, and I'm going to go down to Observing with NASA. So let's see if I can get that to come up. There we go. And this is a part of the website. You don't need to log in. You don't need to provide any passwords. You can just go there. Anyone can go there. And they have some things you can do down here.
Right, just one. Can I just stop you a moment, Lou?
Yes.
Nothing's changing on the screen.
It changed on my computer. I wonder why it's not changing on the screen. Well, we may have to do a poor man's version of this. All right, that's okay. We will adjust.
Okay.
Hang on. We're gonna. This is the poor man's solution, as they say.
Right.
No?
Well, hang on. Let me put it back on the screen. Right.
Well, I may, Andy. Let's do. How about this?
No, that's all right. Now it's moved on to the next screen. Excuse us, viewers, while we sort the technical issues out.
Never use the web in real time. That's right.
Yeah.
All right. So let's continue with this, and we go over to Control Telescope here.
Right, that's working now, I think. Yeah, that's fine.
Yeah, that's better. Yeah.
Yeah.
There we go. All right. And it gives you a whole group of things you can observe, from the moon and planets and the sun to galaxies, star clusters, nebula. A really nice collection of things in the sky that you can observe.
Wow, that's easy.
Okay. It's so easy. So let's say you wanted to look at the Orion Nebula. So I pick Orion Nebula. And it gives you some control over your observation. It asks you, you want to something really zoomed in or far out. Let's say a half a degree here. Let's see what happens if I select that. Okay. Time exposure. Well, it's a nebula, so let's give it a lot of time to collect photons. We'll say 60 seconds. And it tells me, oh yeah, that's the optimal exposure time. Filters. I can choose filters. I think for Orion, I won't. Okay, just like that. And you continue. Then you put in your email address, your age. I'm not sure that's a requirement, or gender. I'm not sure that's required. You might want to. This is generally people in the United States. If you're from England, I don't think you have to submit all that. How often do you use it? How comfortable are you with astronomy? And may we contact you about future use? So you fill all that in. Let's see if I can submit without putting. I think I have to put my email address in. Well, I'll go ahead and do that. Most people know it anyhow. Okay, there we go. So let's see if I can submit just with that. Nope, it wants everything else. Okay, all right. When you submit this, it goes to Smithsonian Astrophysical Observatory, and they feed that information or send that information off to the appropriate telescope. The telescope then the next day returns your image in an email to you because you've typed in your email address. And you get to see the image that it produced, but that's not all of it. because there's an image analysis tool up here that they cryptically call JS9 or JS9-4L. And you can go on a tour of things if you want. Here's a kind of just a previous image. And there are just a whole bunch of things you can do with this image to lighten it up, darken it, stretch it, colorize it, all kinds of things. Let's see, we'll give it I like the word magma. Let's give it a magma color, see what that does. It gives it a little oranges. Okay. So you can process it. And frankly, the images that you get initially might not seem that great, but once you image process them, you can get some really nice images out of that.
Wow.
So again, this is a free service, no login required. You'll get your images back the next day, and you can play with them either using the Micro Observatory image analysis tool or your own, and it's pretty cool. So I'm hoping next week we may have some students from my classes send in their images, and you can see what this actually can do. In the meantime, have at it. It's yours to control.
Okay, so can you just go over again how you got to where you got to?
Yes, I selected Observing with NASA, which is on the left bottom part of the landing page, and then I selected Control Telescope. We'll do that again.
Yeah.
And it gave me a list, kind of a matrix of objects to observe. And I selected one.
It's so easy to use, isn't it? Because sometimes these robotic telescope things can be really complex if you're not an expert.
Right. This was designed specifically for teachers and students.
It's wonderful, isn't it?
It's been through a number of iterations of the user experience and user interface. So, yeah, it works pretty well.
I'm impressed. That's really good.
That is good,
Thank you very much for that, Lou. Thank you very much indeed. So there we are.
And if any of our viewers do try to use it, send your images in.
Send the images in, absolutely.
We'd love to see them.
Email them to spaceodditieslive@gmail.com. So,
I'll definitely be having a look at that, because I used to be a member of SLU, which again was a robotic telescope company. And they used to do almost like this, where you could choose a list of objects, or you could even go on to an advanced where you could actually put coordinates in, and things like that. So, highly recommended. Don't be afraid to use these tools. They're there. Some of them are, it's like this one, Lou's saying. I think the best thing about it is it's free. And we all know.
Absolutely.
We all know.
And easy to use.
Yeah.
I mean, as you said, Lou, for education, for children especially, as you said, they're not big telescopes, but, for children, that must be so thrilling for children to select their object and then, the next day have their image sent to them. That must be a really good.
Yeah. And even at the senior high school or the college level, you have to select your aperture filters and so on. So there's a bit of
starts you on your way, doesn't it? It's really that's really good. That's clever, that is. Because I know there is a version in this country where they use schools can use I think it's in the Canary Islands, where they've got telescopes that you can log on to. Pete used to teach on this, so I can't remember what it was called now. But if I remember, we'll sort it out, and then we'll get you the details. And that was through schools, if I remember right. So
yes, I think it was.
Yeah.
Okay, then moving on. This week's news. So just give me a chance to sort myself out here, and let's have a look at what's been in the news for this week. So first in the news this week. Daz will be talking about the Carrington event shortly, but for now, there's news of the discovery of a much earlier Carrington-type event. Now, a Carrington event was an extreme solar storm, essentially, that hit or was observed to hit the Earth in 1879. But some researchers working on a French river, looking at a submerged ancient forest on a French river, have, first of all, they discovered that there was a spike in carbon-14 dating from 14,300 years ago. And when they looked at Greenland ice cores from the same time, they found a spike of the radioactive isotope of beryllium from 14,300 years ago. Now, the beryllium could only have come from a solar event, a solar storm that hit the Earth, either due to a massive solar flare or a coronal mass ejection from the sun. But the only explanation is that. And the event is estimated to have been 10 times more powerful than the Carrington event. Now, I've just briefly explained what happened with the Carrington event. It was an event that occurred during the time, of course, when people were using telegraph for communication, and it burned telegraph wires in the United States. And there's an unconfirmed report that a telegraph operator received a shock from his equipment, and which knocked him unconscious, and he woke up with a paralyzed arm. That's unconfirmed, but it is a story of the time. It was in the news at the time. People were getting electric shocks off doorknobs, brass doorknobs, believe it or not, all over the place. And it's seen as, a really notable solar event that, if it happened today, would fry electronic circuits over the planet, or at least the hemisphere facing the sun. And all sorts of other effects, knock satellites out. We know that this happens. There were 40 Starlink satellites from SpaceX that were knocked out by a solar event just a couple of months ago. And this was not because their electronics were fried, because the coronal mass ejection on the sun that caused the solar storm was one of the effects of it was that it increased atmospheric drag on the satellites. The Starlink satellites had been launched the day before. The atmospheric drag was increased, so because they hadn't yet achieved the correct distance from the Earth, they were on their way to their final orbits. They were still in low Earth orbit, and the increased atmospheric drag dragged them back into the atmosphere, where they burned up. So SpaceX lost 40 satellites that were recently launched. So, if these big events happen today, like the Carrington event, there would be widespread chaos and disruption. Electrical grids being knocked out, satellites being knocked out, electronic devices around the planet being fried a bit, and it would be terrible. But this event 14,300 years ago was 10 times more powerful than the one in 1879. But Daz is going to tell you a little more about the Carrington event after the news. So that was quite an interesting discovery. Also in the news, don't know whether you saw this, the Webb has been looking at the exoplanet WASP-17b, and it's basically discovered the presence of silicon dioxide or quartz in the atmosphere. This is the type of silica that you find in sand. So basically, this exoplanet has got clouds made of sand, and this is the spectrum from the atmosphere. You can see there's a curve that it would look like if there were no quartz clouds or silica clouds, and then obviously there's a peak in the Webb data at that point. So this is a weird planet that has got sand in the atmosphere blowing around like a massive planet-wide sandstorm. So a bit like what you get on Mars. But anyway, this was an amazing discovery from the Webb. Exoplanets just get weirder and weirder, and we love them for that. Anyway, moving on, NASA's probe Juno has made a close approach of Jupiter's moon Io. This is a wonderful image from Juno. It's the best image taken of Io since the Galileo probe in the 1990s, and it's actually better than the Galileo probe because obviously the cameras these days on Juno are much higher resolution than what Galileo had in the 1990s. And it was taken just a couple of weeks ago, and it was taken from a distance of 7,230 miles, so quite close to Io. And I think you'll all agree, would you not, that is an absolutely beautiful image of Io, the best I've ever seen.
It is.
Yeah. And of course, Io is the most volcanic world in the solar system. It contains the first active volcanoes ever discovered beyond the Earth. And in fact, we now know that there are more than 400 active volcanoes on this little moon of Jupiter. And there may well be more that we don't know about. Okay, next news item. Don't look up. This horned comet is heading straight for the Earth. Now, I wanted to write the headline like that to show you what to look out for in the news over the next several months, because there are going to be all sorts of erroneous claims made about this comet, and I've already seen a headline that said it was heading straight for the Earth, and it's horned, and it's called the Devil's Comet. What's this comet all about? So basically, this is comet 12P Pons Brooks, and it's what we call a cryovolcanic comet because it erupts with ice volcanoes. And it is actually coming our way. It is in a 71-year orbit around the sun. It's 18.6 miles across, so it's quite a big comet, as comets go. This month, just in October, it's undergone 2 explosive eruptions, and the material ejected in those eruptions has formed sort of 2 lobes of material that some people say look like the devil's horns and other nonsense. But that's what the comet looks like after its 2 eruptions. It is coming this way. It will make its closest approach to the Earth next year. And in fact, on April the 21st is its closest approach, but it's not heading straight for the Earth. It's going to pass 144 million miles away from the Earth. So, just be wary of all the hype that there's going to be about this comet inevitably in all the trashy news between now and April. It may turn out to be a naked eye object, as ever with comets. What did Patrick Moore say, guys?
We don't really know.
We simply do not know. So it's always difficult to predict comets, especially one like this cryovolcanic comet, because there may well be future eruptions. There may even be bigger eruptions, which will make it brighter. At this point, we don't know. But we will keep an eye on it, and I'm sure Roger will be reporting it before too long, coming into the night sky over the next several months. So look out for that one. Here's what its orbit actually looks like. You can see from its orbit that it's going to pass quite a considerable distance from the Earth. So again, don't listen to the rubbish that's in the media and on the internet about this. Now you know the facts, and you can tell everybody else about them. Here's an actual image before and after its latest eruption, one taken on October the 5th, one taken on October the 7th, and you can see the increase in brightness and apparent size because of that eruption. So there you are. There's an interesting comet to look out for coming to a sky near you next April. There's been a lovely new atlas of 400,000 galaxies made available to the general public as well as scientists. It's quite an interesting gallery. It's called the Siena Galaxy Atlas 2020, and you can search for it easily enough. There is a long web address there, but if you search for Siena with one N Galaxy Atlas, you'll find it immediately, of course. And what's different about this Galaxy Atlas, because there have been other Galaxy Atlases, this one has got 400,000 galaxies in, so it's a big atlas, but usefully, as well as images of every galaxy, it's got the light curve across each galaxy. That is to say, the light intensity going from one side of the galaxy to the other. And that's very useful if you're researching galaxies, useful information to have. So this is available to the general public. And there's the address, https://sga.legacysurvey.org. And as it says, this promises to be a goldmine of galactic information for scientists aiming to investigate everything from the births and evolutions of galaxies to the distribution of dark matter and propagation of gravitational waves. So there you have it. The first such survey to contain light curves of galaxies. So astronomers who do research galaxies are obviously rubbing their hands with glee at having this available, but it's available to you too. So there's the address. We will pop that in the description of the video as well. Okay, now, interestingly, the NASA's InSight lander, the late lamented NASA's InSight lander, which finally ended its mission after receiving just too thick a coating of Martian dust, and therefore unable to recharge its solar panels. One of the things it detected was a big Mars quake, and at first astronomers thought that it was the result of an impact on Mars of some sort, but now they don't think it was, and what it was quite surprising. Here's the event in question. It happened on May the 4th, 2022. It's the strongest earthquake, or Mars quake if you like, ever detected on another planet. You can see the peak of the Mars quake there, and the ones at the bottom are just sort of general background noise. But this was a strong Mars quake, and what astronomers think it was actually big tectonic movement inside Mars. Now, we've always known that Mars has not got any tectonic plates that we know of, but it does have internal movement because its core has not quite cooled down to nothing. Its core is not frozen, and every so often things inside the planet shift. At the moment, scientists are still researching exactly what shifted, but something pretty big shifted inside Mars, causing that huge Mars quake. Here's another fascinating story. The most distant FRB ever detected. What is an FRB? An FRB stands for fast radio burst, and these are bursts of radio energy that last typically for anything from a few thousandths to up to about half a second. They're coming from all over the universe, and they are incredibly powerful, and they happen, regularly. We see several every day sometimes. And this is the most distant of those yet seen. We don't really know what causes them, or to be more exact, there may be several things that cause them. We don't know if one is the predominant one, but let's have a look at this one. It's the most distant ever detected, and it happened 8 billion light years away. Or to put it another way, it happened 8 billion years ago because, of course, being radio waves, they travel at the speed of light. So this is an ancient FRB that has just reached the Earth after 8 billion years, which is quite a thought in itself. It lasted less than a thousandth of a second. Now, are you ready for this? Hang on to your hats. But it released more energy than our sun does in 30 years. Now, I can't comprehend the amount of energy that is. Guys here, I mean, isn't that an amazing fact? Can you comprehend that? I can't.
No, not really.
No.
I just lost my hat.
Yeah, well, there you are. I knew you would.
It blew his hat off.
Yeah, you weren't holding on tightly enough. Isn't that an amazing fact, though, Lou?
It is. Yeah.
It's if you think of how much energy the sun releases in 30 years, this thing released it in less than a thousandth of a second. So it was obviously a pretty major event. Now, this was detected by the wonderful, powerful ASCAP telescope in Australia. Such is the capability of that telescope that they managed to nail down where it came from, and its source was tracked down to a small group of merging galaxies, 8 billion light years away. So, even to get that is incredible resolution at 8 billion light years. So, we don't know exactly what caused it. There have been lots of ideas put forward for what these FRBs are all about. One of the promising contenders at the moment are magnetars, which are ultramagnetic neutron stars that have, magnetic fields thousands of millions of times stronger than the Earth's. The magnetic field in a magnetar is so strong that if it were at the distance from the moon, it would pull the keys from your pocket. So that's how strong the magnetic field is. And that's one leading contender, but we don't know why. Although there's a new theory this week as to exactly how this happens. I haven't had time to write up, but I will for next week, which involves bisecting jets. But we'll talk about that probably next week. So that was an unbelievable event to happen, and as I say, its cause was unknown, although we know pretty much where it was. Now, SpaceX have been busy with the Starship. Now, you may not have seen this before, but this is a special type of Starship. Nobody really knows what it's for. It's distinguished from the others by the fact that it's got no heat shield, so it's not intended to come back through the atmosphere. And similarly, it has no flaps. So this is definitely a launch into orbit, and it's not going to come back. But what exactly SpaceX intend to do with this, we don't know. But this week they tested one of the, or only one of its Raptor engines, the first time this particular model of Starship has been tested in a static fire test. And that seems to have gone very well. It's thought that this could be the first model of the tanker starships that SpaceX are going to use to refuel the Starship that will put humans on the moon. Because for that, the plan is that what will happen is that the HLS, or the Human Landing System, the lunar Starship as it's called, will take off from the Earth, be refueled in orbit by tankers, up to 10 of them in fact, and then go to the moon. There we are, and this is what the S-26 and S-27 look like. As you can see, they're very different from the conventional Starship, if you want to call it that. The Model S-28 is shown on the right, but SpaceX have not said exactly what S-26 and S-27 are intended for. And there you have the news, guys, for this week.
Very interesting.
Yeah.
Yes, of course.
I'm going to sleep tonight. That's too much information.
Of course, there's SpaceX are also in the news, plus other rocket launchers, about the FAA and the red tape that they have to go through to obtain launch licenses, and the fact that now because there are more and more launchers coming onto the market, that the FAA can't keep up, and they're struggling. Plus, the regulatory framework is being, which is supposed to have been worked out, is being delayed, and things like that, and it's been constantly changed. And of course, they're saying it's holding everything up at the moment.
Well, the people holding it up at the moment are the Fish and Wildlife Service.
Yeah. That's a slightly different issue. I know what you're saying, Andy.
Yeah.
But they're saying that also with other rocket launches, especially with the speed that SpaceX are launching now, with all the other providers, that licenses are being delayed and people are sort of like missing launch dates. And they're asking for basically more money to be put into the FAA. They're not criticizing what the FAA about the licensing. It's about the thing that it hasn't got the manpower or the know-how of how to achieve the goals that they're trying to achieve, with basically getting licenses out quick enough so that people can do their launches.
Well, personally, I think that what is needed is a separate agency to deal just with spaceflight licenses, because the FAA have to look at after the skies of the United States and rocket launches, and they're underfunded and understaffed. They've been saying this for a long time, mind you, that they haven't got enough people working for the FAA. So I think that a separate agency that can get the licensing process effected quickly should be set up to help the space industry, because this is going to happen every time now. It's not just SpaceX. There was a congressional hearing last week, and Blue Origin were there, Virgin Galactic were there, SpaceX were there. Funnily enough, the FAA wasn't invited to the congressional hearing, which was a bit odd. But what came out of that was that all of the spaceflight companies are saying, look, we're applying for these licenses and it's taking forever to get them to launch. And the guy, the VP of SpaceX said, look, we've got a spaceship that's ready to fly and we can't fly it because of red tape. So something needs to change, definitely. I mentioned the Fish and Wildlife Service because after the near disaster of the April launch of Starship, its maiden flight, you remember the damage that was caused at the launch site, with chunks of concrete flying everywhere, even out to sea. And the Fish and Wildlife Service were a little bit peeved at that. And they are holding an investigation. And by law, once the FAA give the Fish and Wildlife Service the report, which they are hoping to do by the end of October, the Fish and Wildlife Service have 135 days to reply and complete their investigation. If they use the 135 days, that means Starship isn't going to fly till the spring. And that's quite ridiculous, if you ask me, because it's just unnecessary. I mean, I know it's important to preserve the fish and the wildlife. Of course, it is. Everybody wants that, but you just get the feeling there's so much bureaucracy being piled onto the actual business of space flight now that things need to change dramatically. So there we are. All right then. Anyway, but we will talk about that more on our next edition of Rockets Away, the other series of videos that we're doing, which we talk about rocketry issues like this. And we also profile one of the international space agencies. We will be recording the next edition this weekend, and it should be out on our channel next week. And in this edition, we're going to be profiling. We're going alphabetically. We did Algeria last time. So this time it's the turn of the Argentinian Space Agency. We'll be profiling them. Who are they and what do they get up to? So keep your eye on the channel for the Rockets Away videos. There is a Rockets Away playlist on the channel with our first one in. So keep your eyes on that. And if you're interested in space flight and rocketry and what's going on in the space industry, we discuss that and profile a space agency. So we hope you'll join us for that. Now, we mentioned the Carrington event earlier, and I know a man who's going to tell us all about it. So, Daz, we had technical trouble last week, so let's hope we don't this week. So, take it away, Daz.
Right, can everybody see that, especially online? I'm waiting for it to come up on mine. Basically, we're talking about Carrington events, and it's usually about some of the hysteria that forms around them. But before I start, all of the information that I've gleaned, and also it's a very good resource, is Dr. Tamitha Scoff, the space weather woman, and she's an expert in space weather, and she's got all the qualifications to talk about this. And it's if you go on there, you can if you sign up to her, just look for Tamitha Scoff, space weather woman, and she has a load of what she calls mini courses. Now, the word mini, I would say, is used a bit flippantly, I think. Really, these courses can be up to 3 or 4 hours long. Now, that seems a bit daunting, but as Tamitha says, these are you're supposed to digest this course over a whole month. They don't expect you to sit there for 4 hours and digest everything that Tamitha says. And she'll explain everything in very simple terms. And you can learn. I've learned so much from her. And there's about 4 or 5 different categories that you start with sort of like a basic overall course, and then she splits down all the different types of events that happen on the sun that will give us space weather. Now, you're probably asking, why are we actually worried about space weather? Well, it's basically space weather is important. If you think of all the technology we take for granted, like GPS and traffic apps on mobile phones, drones, the UAVs that fly above our heads, high altitude airline flights, satellite internet, satellite phones, direct TV, even radio. All of these things are directly affected by space weather. As we become more reliant on smart wireless technologies, our dependence upon space weather grows. Even today, emergency radio communications, such as disaster relief agencies like the Red Cross, depend on it. And this is Tamitha's own words. She said she's working to make credible space weather forecasts as common as the weather forecast to see on the evening news. And it is highlighted underneath our pictures. So basically, what I think we'll do now is we'll just sort of start talking about the Carrington event and what it was all about. As Andy's already mentioned, the solar storm was on the 1st of September, 1859, and it's become known as the Carrington event. So Right, let's move on. I think because 1859, we're talking about Victorian times. I think we need to set a little bit of historical context to this. They did have ground-based telescopes like this at Portsonsdown in Ireland. This is the Leviathan. It was owned and built by Lord Rosse, and it was a great reflecting telescope. So we did have access to telescopes, but we didn't have any access to space assets, if you want to know like that. To view solar events, everything had to be done through optical light and through the window of our atmosphere, because we, like as I said, we didn't have any space assets. There was any flash filters to show light in multi wavelengths. Sun observations were done by projection or through heavily smoked glass plates so they could see the disk. They also had zero knowledge of the workings of the sun. They didn't know it was actually a massive nuclear fusion reactor in action. And they had no idea the sun created space weather that affected us on Earth. And as I said, it was. This is all they knew. They didn't know what was causing. Of course, they would have seen auroras, but they didn't realize what was actually causing them. But they were able to record magnetic events here on Earth using magnometers, which we'll come on to a little bit later on. So as I said, they had no space assets, so they had no space telescopes that could image the sun's surface and its atmosphere using different wavelengths, because of course we know we have the visible light that we can actually see, but the spectrum of light actually spreads on both sides to very low frequencies to very high frequencies. And with the advent of space telescopes and the fact that we could use X-ray telescopes, infrared telescopes, and things like that, we can actually peer into the atmospheres, because it's like an onion. It's basically the atmosphere of the sun is like an onion, and each layer as at different temperatures, and so will show up in different wavelengths. And as you can see on here, we've got 6 pictures, all taken of exactly the same time, but using different wavelengths. And you can see different textures, different events happening. So you're actually peering through the atmosphere of the sun, and you're actually picking out the events that are happening. And of course, when you're looking in visual light with a standard filter, all you can pick out is sunspots. You can't even see ejections or anything like that on the side, or prominences. So this is what the Victorians were hampered by. But the actual observation, as I said, was made on the 1st of September 1859. Andy, can we get rid of the pictures at the bottom, please? Oh, he's not there. And it was astronomer Christopher Richard Carrington, that's him on the left, the chap with a fine beard, was observing a large collection of sunspots visible on the surface of the sun and drawing them in great detail of what he saw. He was using his brass 115mm refractor telescope, but unbeknown to him at the same time, there was a chap, another astronomer, Richard Hodgson, another UK astronomer, observing exactly the same sunspot region. And both of them, what they actually witnessed was there was a blinding white light on the surface that actually emanated from these sunspots. So I hope you can see. This is the Red Hill Observatory where Mr. Carrington did his observations on that day. This was all later moved to a new astronomy observatory in a later date. So there we go. Now this is what the sunspots would have looked like, except the sunspots they were observing were more in the center of the actual sun itself. But it had been an active region that had been there for 3 or 4 days, and they knew that it was actually coming round to almost be head on with us and all that. So they were observing it. And what you can see here is these dark spots. The very dark spot is the coolest area. and then that's the umbra, and then you've got the penumbra around the outside. And I won't go into what these really are, what's actually causing these spots, but it's where the actual temperature is cooler, and that's why they're darker spots. And as you can see, there's quite a few spots in this this region, but what you have is like this spot here. You can see two spots quite close together, and you will have magnetic bands breaking through the surface, forming a loop. And that's all I'm going to say. And I'm not going to go into too much detail this time. If people would like to know, then I can do a second presentation later. So that's the sort of sunspots he was looking at. Now, I think you can see it on here. Now, just before noon, both Carrington and Hodgson witnessed a very bright white light erupt from this sunspot region, which is, can you see my cursor? Yes, no?
No.
No. Okay, then. It's sort of like the 2 o'clock region, just a little bit in from the surface. You'll see a very bright region. And then just before 12 noon, there was a mighty big flash. They said it was quite blinding at the time. And as you can see on the right-hand side, on this image, I don't know if you can see that image, that area has brightened, and you can see diffraction spikes coming off of it. That's where you've had what they call a white flare, white solar flare. Now these are quite rare, and not very rare, but they're rarer than what normal flares are. Of course, with the equipment they had at the time, the things like CMEs, coronal mass ejections, and solar flares were virtually invisible to the eye, except when you had one of these very bright events, a white solar flare. So that's the sort of thing they saw, and I hope you can see the diffraction spikes on that, where it's actually grown in intensity. So on the image on the right. So here's Carrington's image. And as you can see, Carrington is also renowned. If you notice on here, you've got sort of like latitude and longitude lines on here. Now, he's the chap who is given the honor of actually designing this. It is a way to actually plot on the sun's surface. He devised this this system. Now, if you see, you can see you've got all the the large area of the sunspots. Now, in the middle, you'll see like what looks like two maggot type things, now labeled A and B. Now, these are what are called, they're actually called magnetic arcades. And this is just after the event has happened. We've had the solar flare, the eruption has happened. And what happens, these white spots is the sun actually repairing the magnetic fields that have just broken away. And you can see that it started in position A and it moved to position B. So this is the detail that he was able to draw. And for him to be able to do this, those areas had to be there for 3 or 4 minutes for him to be able to mark them onto his.
It's quite a remarkable drawing, isn't it? Really,
it is. It is. And as I said, he was the chap who was instigated this this grid design so you could actually plot them. Now, one of the important things is if you look in the bottom right corner, you can see 0 degrees. Now, that means that this was almost head on. Luckily, it wasn't. This will be something that I'll go into another program show that we'll do. But this was nearly head on. So this was really directed almost right at us. So we were going to get a big effect from this. But of course, Carrington didn't know any of this, nor did Hodgson. The next day, I can't see what it says at the top. So what they had witnessed was a white flare that had never been seen before, but with the naked eye. Also, unbeknown to them, the flare was accompanied by a coronal mass ejection, and this is where a big flare, a mass of the sun's actual plasma is thrown into space, and this is what will give us partially the storm. Because you get a magnetic storm and you get a radiation storm associated with these events. Normal flares and CMEs are naked to the are invisible to the naked eye, as I said before. Carrington was able to add them to his drawing, the worm-like artifacts, which were left there, lasted 4 or 5 minutes. And as collaboration, a while later at Kew Observatory, a magnetometer, oh God, registered a large spike in the Earth's magnetic field. And it was a huge one. The huge spike was caused by the magnetic storm that was created by the flare traveling at nearly the speed of light and then arriving at Earth. So this actually arrived at Earth almost about an hour after the actual flare. So, of course, we saw the... cheers, Andy. So we saw the... so he saw the actual brightness, and then an hour later, this magnetic storm actually hit. But the main part of the storm, and this is something that is important, arrived 17 hours later. And basically, they usually take 3 to 5 days. So there was so much energy behind this CME and this solar flare that it had traveled the distance between the sun and the earth in 17 hours. This is the main part of the storm. Now, this main part of the storm, so what did we actually notice? Here's the magnetometer reading that I was saying about from the Kew Observatory. And you can see a large, I'm using my cursor again, you can't see it. You can see the big spikes. And in fact, on the lower trace, you can actually see it was more than one event. It came in a couple of ways because this was a repeat event. It happened 2 or 3 times in very quick succession. And what happened is the first flare was moving away. And this region had been active for quite a while. And what it was doing, it was moving so fast, it was catching up with other previous flares or events. And it was gathering up all this energy that was already in these slow-moving storms, and it was adding it to its storm. And this also increased the intensity of what actually happened. But as you can see, there was 2 or 3 different events that came in afterwards. And this is what gave us an event that lasted 3 or 4 days. So this, and there is at the bottom here, I don't know if you can see it, there is some faint writing that was written by the observer at the time at the Kew Observatory, who wrote that these times coincided nicely with what Carrington saw when he was drawing his sunspots. So, so what did we actually see? The most, of course, what everybody noticed was the intense auroras that everybody saw. Now, we know auroras usually tend to sit towards the upper latitudes, nearer the north and south poles. But this aurora the radiation storm was so intense that the auroras were seen by eye. Remember, we didn't have cameras. We didn't have our trusty little cell phone to take photographs. These auroras were seen down to as far as 20 degrees above the equator, just above the equator. And I'm assuming that if you did have phones, it would have been able to been detected at the equator. So the aurora over the Rocky Mountains in the United States was so bright that it woke the gold miners, who began preparing breakfast because they thought it was morning. And people in the northeast United States could read a newspaper by the aurora's light. This is what was actually they could actually see. But there was also, and of course, it was so intense that people said it was like daylight. But also, it had all the colours of basically all the rainbow in there. So it was something to behold. So, right. So on the Saturday, September the 3rd, the Baltimore American and Commercial Advertiser reported those who happened to be out late on Thursday night had an opportunity of witnessing another magnificent display of the auroral lights. The phenomenon was so very similar to the display on Sunday night. Thought at times the light was, if possible, more brilliant, and the prismatic hues more variable and gorgeous. The light appeared to cover the whole firmament, apparently like a luminous cloud through which the stars of the larger magnitude indistinctly shone. The light was greater than that on the moon at its full, but had an indescribable softness and delicacy that seemed to envelop everything upon which it rested. Between 12 o'clock and 1 o'clock, when the display was at its full brilliance, the quiet streets of the city, resting under this strange light, presented a beautiful as well as a singular appearance. That's quite poetic, really. But it gives you an idea of what actual people were viewing and what they thought of it at the time.
That's when people took pride in the language that they wrote in newspapers.
Exactly. No horror stories.
No.
Now, this diagram shows you where the actual visual eye reports of aurora sightings. And as you can see, all over the United States, and even some in the mid-Atlantic, they were reported. And as you can see, the one furthest south is at it was the 20th down to 20 degrees. Sorry, Lou, you say something about newspaper reports?
Yes, they didn't have social media or email,
exactly.
A lot of the reported sightings were from newspapers.
And it may interest you to know, Lou, talking about communication, that the first transatlantic cable had only been completed the year before. The first transatlantic telegraph cable had only been completed in 1858, the year before. So news of this was able to spread quickly across the Atlantic, more than would have been possible had it been, just newspapers. So a truly one of the first global events, really.
Yeah, because if you look over towards the right, where you're outside the USA and the darker areas, obviously there are aurora reports reported in other parts of the world. And if you notice, right on the right-hand side towards the bottom, there is one which is about 15 degrees. Hang about, no, it's about 10 degrees. Yeah, because they're in 20s, aren't
degrees,
they?
Yeah, in India.
Yeah, in India. So, and actually, no, that's probably actually a magnetometer
right.
reading.
Yeah, there's no color key on this, is there?
No. I'll probably cut that off just to get it out there. But that gives you an idea that the auroras were seen as far down as 20 degrees. Now, remember that, because that's not the biggest for later on. Now, there was another effect which not a lot of people will realise that happened at the actual time. It was only when the papers got hold of the information and they reported it. And Andy mentioned it earlier on, and that was disruption and damage to telegraph systems. Because of the geomagnetically induced current, geomagnetically induced current from the electromagnetic field, telegraph systems all over Europe and North America failed in some cases, giving their operators electric shocks, as Andy said. Telegraph pylons threw sparks. Some operators were able to continue to send and receive messages despite having disconnected their power supplies.
Wow.
Now, the telegraph system was operated with batteries because, of course, we didn't have the big electric networks that we have today.
No.
Now, when it talks about, I suppose with a little bit of explanations required here. Now, with the suppression of our electromagnetic field, which protects us, more of the radiation and other energetic particles were able to reach the ground. And what happens, this induces a current in the actual Earth's mantle, which is very conductive. So it induces more current in there. Now, this actually then induces a very small, I will say very small, current in the telegraph lines. So if you've got about an inch of telegraph line, you'll have a very, very small increase in electric power. But of course, the telegraph line stretched for hundreds and hundreds of miles, and the increase in voltage, or whatever you want to call it, in the actual power lines grew and grew and grew. So what they were able to do is, it says there, is they were able to disconnect their power supply and carry on working. This is the sort of equipment they were using. Looks like a little harpsichord or something like that. But you can see they use ticker tape. These are the keys. Well, use them, I think. You can see the keys for actually sending the messages. Now, what was happening was that, as I said, they disconnected their batteries, but they were able to continue transmitting to each other. Now, this is I hope you can see this. This is a map showing all the cables of the time. And as I said, they stretched for hundreds and hundreds of miles. So the currents induced into these wires over, as I said, it was only a small amount, but it was incremental, and it got very, very, very large. So they could disconnect their batteries and continue.
Wow.
Now, this is can't see at the top now. This is a conversation carried on between two operators of the American telegraph line between Boston and Massachusetts and Portland, Maine, on the night of September 1859, and reported in the Boston Evening News. So, Boston operator to the Portland operator: please cut off your battery power, your battery, that's the power source, entirely for 15 minutes. Portland: will do so. It's now disconnected. Boston: mine is disconnected, and we're working with the auroral current. How do you receive my writing? Portland: better than with our batteries on. Current comes and goes gradually. Boston: my current is very strong at times, and we can work together without the batteries, as the aurora seems to neutralize and augment our batteries alternately, making current too strong at times for our relay magnets. Suppose we work without batteries while we are affected by this trouble. Portland: very well. Shall I go ahead with business? Boston: yes, go ahead. So they disconnected their batteries, and they were still talking to each other. And this actually went on for quite a few hours afterwards. Okay. So that's what we actually saw. That's the only two things that we can really describe, because again, as Andy said, the telegraph would only just become very, very common in use. The new, as you said, the transatlantic cable had just been laid. But what then happened was reported throughout the world, and everybody sort of like cottoned on to the effect. Now, as I said, Carrington had no idea that the space weather even existed. He was able to deduce and put together the two events, and said maybe what's happening on the sun is what's caused what's happening on Earth. And he wrote a report for the British Astronomical Society, and so did Hodgkin, reporting his reports. When the chap at the Kew Gardens Observatory saw what was written, he introduced the magnetometer information, and that's how we then did, the actual study of space weather actually started to begin. Now, with these two events, what effect did it have? And why is it grown up a lot of myths and scaremongering that goes on now? Now, this has been reported as the strongest the solar storm that's ever been recorded. But we know that's not right, because using cores and tree ring analysis, they have found that there have been lots more Carrington type events happening throughout history. But what we've got now is basically we got both in the press and online. You can find these events described as doom and gloom speak, like Carrington-like events are mega flares, kill shot, or micronova. Well, I'd like to know what a kill shot is. Armageddon from the sun or the wrath of God. Power grid killers. Basically, any space weather event that will spell doomsday for the Earth, weakening magnetic field, and to all electronics on Earth. Well, I don't know where they get the weakening magnetic field from. Electronics will burst into flames and buildings will burn down. Carrington event will kick us back into the dark ages. The radiation will be lethal to all on Earth. Now, these two events, basically, that is all rubbish. It's Hollywood fodder. It's for the next blockbuster. We have experienced far more Carrington events since this event happened in 1859, but we're all still here. I'm going to end it there, but I can it's sometime. Yeah, I'll end it there. It's sometime. If people want to know a bit more about what actually is happening during an event like this, how it's created by the sun, and also what effects it will have on us today if one hit us, then I can do another show. I've already started to form it, so hopefully in the future I'll be able to fill you in with all the details, and you might be interested in learning how these events occur, what they are, how do we classify them, and you'll find there's some really amazing events that you probably don't know about that have happened in the past. But I'll leave it there. I don't want to give away too much. So I hope you
right. Okay. Thank you, Des. That was most interesting. But as you say, it's the most famous solar event, but not really the most.
Yeah, it's as I said to you guys earlier. There are 5 things you need to look at, and that's the speed of the event, how fast it travels. Remember, this one arrived. The actual magnetic storm arrived an hour later, but the big storm itself arrived within 17 hours, and they usually take 3 or 5 days. You've got the radiation storm, you've got the effect that it has on Earth, and there are 5 categories. Now, the only reason that they say the Carrington event is the biggest storm ever recorded is it's possibly number 1 in maybe 1 or 2 categories. Some of them you could say it's equal. It was equal first, but in all the others, it appeared on the podium. It was either first, second, or third. All the other events that have happened since that have beaten it have not appeared on the podium anywhere else. So it's how to classify these events is very, very hard to do.
Well, I'm sure viewers would agree with me. We'd love to see the second part of that because it is most interesting. When we talk about global media events, we've just been talking about the effects on the telegraph system. And there was actually another major, this time a catastrophe associated rather nicely with telegraphs. And that was the Krakatoa eruption of 1883. To which I love this fact because it's a beautiful symmetry. So when events used to be reported around the world, they would go, by before telephones, before the telegraph, just basically people sending in written reports, which would obviously take time to arrive. So we're so used these days to events happening in the world and getting to know about them more or less instantly. Back in the 19th century, before the advent of the telephone, both the telephone and the telegraph, it would be a case of journalists around the world submitting written reports. And it might take days or perhaps even weeks for those events to reach the newspapers. With Krakatoa, since 1858, when I said the first transatlantic cable was laid, transatlantic telegraph cable, Krakatoa happened in 1883, and the network had been greatly expanded, so it was rapidly becoming a global telegraph network. And therefore, news of the Krakatoa eruption, that catastrophic eruption that killed 36,000 people, it reached London in just a couple of hours. And there's a really lovely symmetry to this because those undersea cables are made waterproof with a substance which you've probably heard of called gutta percha. Gutta percha is a rubber-like substance, and the only place in the world that the trees from which gutta percha comes from are found, you'll never guess, is in Indonesia, where Krakatoa happened. So there was. I find that a beautiful symmetry of things. Not quite sure why. I've always thought that an amazing fact that the Krakatoa happened in the only place that you find gutta percha within which they waterproofed the telegraph, the undersea telegraph cables. It's a lovely world of facts, isn't it? Lovely universe.
Yeah, it is. It's like I said, like you were saying, that it's the the sensationalism that goes along with these reports and the doom and gloom sayers that have pumped this up to be like everybody's expecting a global. It's like your horned comet.
Yes, exactly.
It's pumped up because that's what sells papers. And you were talking about electrocutions. Yeah, people did get little shocks and things like that from there. And as you said, one bloke did get one right to the forehead, which did put his lights out for a little while. But the another thing, and I forgot to mention, was the ticker tape. It's because the system sparked, it set light to the ticker tape. So of course they were talked about that there were some small fires that were quite easily put out by the staff monitoring these stations. Some of them got minor burns and all that. But of course, once it reached the papers, it's saying that telegraph officers were burnt to the ground, and telegraph operators were seriously injured, which of course they weren't.
No.
But it's these two small events. But it's the aurora and the telegraph thing that is actually created this myth around it. But as I will, when I do the next part of this, you will see that there is need for some concern, but no one's going to die.
No
one.
And while we're talking about language and media reports, I have to leave you with this one, which I thought was just delightful. Some scientists have been researching. You know how people often say, if you've got aches and pains, people always say to you, "Oh, it's a change in the weather." You know, with things like this. I broke my femur, as you may remember, a couple of years ago, and obviously I was in immense pain. And whenever my leg hurts, sometimes, as it does, basically because I've got a thick rod of titanium now going through all the way from my hip down to nearly my knee. It does hurt sometimes, and people say, "Oh, it's a change in the weather," and I say, "No, it's a rod of titanium."
Yeah.
But anyway, so a group of scientists have been researching if there's any truth in this alleged link between a change in the weather and arthritis type pains and other pains in the body. Do you know what they entitled their paper?
Go on.
Cloudy with a Chance of Pain. I love that. I thought that was absolutely brilliant. So well done to them. It was some university in the US.
Well, you could be our Carrington event, sort of like warning system, because apparently if you've got, like you say, you've got rods or you've got implants, metal implants and all that, they can cause some aches and pains when they and it has been studied, but the jury's still out, but they say that it does cause aches and pains in
luckily for
metallic
me, titanium's not a magnetic metal, so I don't think it would affect anything.
You just light up.
Yeah. For the same reason I don't set metal detectors at airports off when I go through, because titanium's not magnetic. So the rod in my leg, and also the titanium in my ankle, from where I broke my ankle in 3 places a couple of years previously, that luckily doesn't set the security alarms off at the airport when I go through. Anyway,
I was going to say, you're
can I just say, we have a new member who's just popped up. Hi, Greg. You are most welcome. Greg says, "Hi, I just joined. What's going on here?" Well, you've missed some fascinating presentations tonight. We've been talking about an extreme solar event known as the Carrington event. We've had the latest astronomy and spaceflight news, and Lou has been talking about micro observatories, and Roger's been doing the what's on in the night sky and the viewers gallery for this week. So, Greg, you are very very, very welcome here. I'm afraid we're just coming to an end. You can catch us here on Tuesdays at 8 o'clock UK time or 3 p.m. EST. And sorry you seem to miss most of the show, but this is what we do. We talk about the universe in all of its forms and everything going on. We are Space Oddities, and that's what we do. So you're very welcome, Greg. Thank you for being with us.
You can always catch up on replay.
Yes. Don't forget that you can watch this video on our channel and youtube.com/@Space Oddities Live.
Hit those likes.
Absolutely. So you can watch this again from the beginning. It will be published. YouTube usually take a couple of hours to actually publish it on the channel after this live stream. So tomorrow, for example, you'll be able to sit back in the comfort of your own home and watch us in its entirety. Just before we go, I'm going to just remind you that Space Oddities T-shirts are available, and you can scan the QR code, but the full description and the details of how to get your hands on the immensely coveted Space Oddities T-shirts, that is in the description of the video already. And don't forget, it's £19 including UK postage and packing. Please add £10 for foreign orders. And we've also got the delightful hoodies in two types, one with a zipper, one without. The one without the zipper, the design is on the front, and with the zipper model, it's on the back. £35 to you, madam, including UK postage and packing. Please add £10 for foreign orders. And Roger is modelling, the delightful pouting Roger is modelling the Space Oddities T-shirt for your delectation and delight. And a jolly good value, and they're really good quality. Mine's been through the wash loads of times now, and so far it's retained its luster, as it were. So that's good quality T-shirts, definitely. And as I say, if you look in the description of this video, you will find full details of how to order. You can order them directly from the company that makes them. So there we are. So thank you, Skull Print, which is the company that does that. We love the T-shirts. We love the hoodies. I'm going to order a hoodie for the winter, definitely, because although we've had temperatures still up around 29-30 during the day here, it's getting rather chilly in the night and the evenings. So I will definitely be ordering one. And there we are. So next week on Space Oddities, I haven't got the faintest idea, but we will, as usual, be presenting lots of stuff for you about the universe. And don't forget, if it's happening in space, it's happening on Space Oddities. We have got a few live launches coming. What's the next live launch, Daz? Can you remember?
Oh, offhand?
No.
Not off. No. I'll say no.
Okay, fair enough. Well,
I know we've got Polaris Dawn, but there is something else that I can't think what it is.
There was, yeah. But if it's a major space event, we will of course cover it live here on Space Oddities. So we hope you join us.
Work commitments permitting.
A final thank you to those of you who have been buying us coffees. I'm just going to put the QR code up one last time for this evening. If you wish to buy us a coffee and help the channel keep going and grow, then your support in coffees is much appreciated. Scan the code, and there you are. And you'll see in the chat a link that's just been posted at the same time. So click on that in the chat if you haven't got your QR scanner handy. I'd like to give big thanks to Daz, to Lou, and to Roger for joining me tonight. We're a bit thin on the ground tonight, but at least we've been here for you viewers. And we will see you back at the same time next week. Now, also don't forget, just a quick plug, keep an eye out on the channel because we are recording the second edition of Rockets Away this weekend, where we discuss specifically spaceflight and rocketry, all the news, and we will also be profiling in that edition of Rockets Away the Argentinian Space Agency. And believe it or not, if you don't know that Argentina's got a space agency, well, they have, and they have actually been extremely active over the years. So keep your eye on the channel in the Rockets Away playlist for that video, which we hope to have up by this time next week. All right, then, viewers, we'll say good evening. Thank you so much for being here. Welcome to Greg, and thank you all the rest of you for being here. Lovely to see you all supporting us. So much appreciated. So from all of us at Space Oddities, we wish you a fantastic week. Have a great weekend. Look after each other. Be kind. Be good. And if you can't be good, be average. And that's what I want to say. So we will see you this time next week. So from all of us at Space Oddities, it's keep looking up. Hope you get clear skies. And goodbye.